So welcome everybody to this latest A2 video on trigonometry, and in this video we'll be continuing from compound angles and looking at some more example questions and work solutions. So let's have a look at this first question. Now this question is very popular when it comes to compound angles, either in a textbook or in an exam. So question 1 says that given that A and B are acute angles and that sine A equals 1 over root 3 and cos B equals 3 over 5, evaluate A, which is sine A plus B, B tan A minus B, and C, which is cosec A plus B. So let's have a look at this first question now. In terms of sine A plus B, plus A plus B, so sine A plus B. Now that, in terms of our sort of trig identity, is going to be equal to sine A cos B plus, because obviously the plus is in the bracket, and it's going to be cos A sine B. So in terms of this, now I've been given the values of sine A, which is not a problem because that's going to be 1 over root 3, and I've been given what cos B is going to be, which is going to be 3/5. Now the problem is I don't know what cos A is going to be, and I don't know what sine B is going to be. So in terms of this, what I need to know is note that they are acute angles. So if I set up what resembles a right angle triangle, and let's say this is angle A. Now using sine A, which is sine theta equals opposite over hypotenuse, that the hypotenuse must equal root 3 and the opposite must equal 1. Now using Pythagoras, what we can then do is, using Pythag, I get that this angle, this length I should say here, is going to be root 2. So from this then, what I can then do is, using cos A, which is what I'm wanting, that cos A is equal to the adjacent over hypotenuse. And in this triangle here, our adjacent is 1 and our hypotenuse is 3. So cos A equals 1 over root 3. Now what I could also do is, if I take this bit of information and I have my angle of B, and using cos, well, cos theta equals adjacent over hypotenuse. So here, from this fraction, our adjacent must be 3 and our hypotenuse must be 5. And therefore, again, by using Pythagoras, I get that this length here is going to be 4. So from this triangle here, I can know that sine theta, or sine B I should say, so let's get rid of that theta and change that to a B, is going to be equal to the opposite over the hypotenuse, which in this case is going to be 4 over 5. So now what I've got are my two other components that we're missing. So this here is going to be 1 over root 3, and this here is going to be equal to 4/5. So therefore sine A plus B is going to be equal to 1 over root 3 times 3/5 plus cos A, which is 1 over root 3, times sine B, which is 4 over 5. And again, if I then go on to simplify all of this, then what do I end up with? Is going to end up with 3 plus 4 root 2 over 5 root 3. And there is my final answer for that one. Now when it comes to working with B, so let's just get rid of this. I'm going to leave those there. In terms of the triangles, and let's just get it. So then working with tan, so for B, we've got tan A minus B. Now using trig identities, this is going to be tan A minus tan B over 1 plus tan A tan B. Now for this I don't know any tans, but again using these I can actually work that out. So here tan A Now tan is obviously going to be opposite over hypotenuse, so that's going to be equal to 1 over root 2. And using the second triangle, that tan B is going to be equal to 4 over 3. So from this, what I can then do is substitute those values in. So I've got 1 over root 2 minus 4 over 3 all over 1 plus, and then it's going to be 1 over root 2 times 4/3. And again, if I just simply bung that into my calculator, I get an answer of 3 minus 4 root 2 over 4 plus 3 root 2. And there is my final answer, obviously with the sort of denominator not rationalized. So moving on to C. Now, in terms of C, you might think to yourself, well, how can I use these triangles to get cosec? Now, the problem is with C, well, there isn't actually no problem, is recognizing that cosec A plus B is the same as 1 over sine A plus B. Now, the good thing is that we've already found out what sine A plus B is, and that's from part A. So if I go back to that, so that cosec A plus B is going to be equal to 1 over the answer I got in A, which, if as a reminder, is 4 root 2 over 5 root 3, which then flips a fraction so that it becomes 5 root 3 over 3 plus 4 root 2. And there is my final answer. So moving on to question 2. Now question 2 says that given that tan theta minus 30 equals 2, prove that tan theta equals minus 8 minus 5 root 3. Now with this type of question, which again is very, very common, what you want to do is ignore the 2 for start off with. What you want to do first, so for this hashtag 1, is find the expression for tan theta minus 30. So that's the first thing we're going to do first. Now again, using the trig identity of this compound angle, we know that tan theta minus 30 is going to be equal to, and again, tan theta minus tan 30 over 1 plus, and it's going to be tan theta tan 30. Now for this, I do know the values, or I should know the values of tan 30, which is just going to be 1 over root 3. So if I then go on to simplify that, I get tan theta minus 1 over root 3 over 1 minus tan theta 1 over root 3. And if I just simply neaten all of that up, what do I end up with is root 3 tan theta minus 1 over root 3 plus tan theta. And again, it's just a case of getting rid of the fractions, having a common denominator, and then going from there. Now, if you're not sure about what I've done there, so for example, with this, what I'm going to do is have it so to try and combine, treat the numerator as one thing. So I'm going to write this as root 3 tan theta over root 3 minus 1 over root 3. So then that then becomes this. And obviously the denominator stays the same in terms of that. And then repeat the same for the bottom. So there we go. Now, in terms of, so once we've got our expression here, what we then want to do is make this equal to 2. So for the second step, so for hashtag 2, what we will now do is make this equal to 2. And the reason why I'm making it equal to 2 because it tells us. So from this, and I'll get a different colour pen, we notice that root 3 tan theta minus 1 over root 3 plus tan theta equals 2. Now for this, what you want to try and do is make tan theta the subject. So from this, what we then do, in the most easiest way of doing that is take this denominator over to the other side. So what we end up with is root 3 tan theta minus 1 equals 2 bracket root 3 plus tan theta. Again, if I then expand that bracket out, I end up with 2 root 3 plus 2 tan theta. Take this 2 tan theta over to the side and take the minus 1 over to the other side, which we end up with root 3 plus 2. Oh no, let's correct that. We end up with 2 root 3 tan theta minus 2 tan theta equals 2 root 3 plus 1. Then we can factorize. So we've got tan theta root 3 minus 2 equals 2 root 3 plus 1. Take this over to the other side, so we end up with tan theta equals 2 root 3 plus 1 over root 3 minus 2. Now at this moment in time we haven't made it look like this, however we have ended up with this. So what we now need to do is just simply rationalize the denominator. So if we now rationalize the denominator, you will end up with the correct proof of that minus 8 minus 5 root 3 QED. And again, I might be a little bit sneaky, but I also don't want to put you to sleep by making this video last any longer than it needs to be. Now with this third question, it says solve the equation of 2 sine 30 degrees plus theta plus 2 cos 60 plus theta equals root 3 for minus 180 to 180. Now for this particular question, it is quite long, but we've got to make sure that we're taking it in terms of components. So let's have a look at working with this first. So if I look at hashtag 1 and I see that we've got 2 sine 30 plus theta. Now for this, what we then need to do is ignore the 2 to start off with, because the 2 is just being multiplied by the function of sine 30 plus theta, and then we're going to use this as our double angle. So this is going to be our A, this is going to be our B. So what sine 30 plus theta is going to equal? Well, it's going to equal sine 30 cos theta plus cos 30 sine theta. And do I need, no, I don't need that bracket. It needs to be a square bracket, so let me just correct that. And then if we then substitute the values of the known values that we know, so we know that sine 30 is a half and cos 30 is root 3 over 2. So then from this, what we end up with, and let's just use green. So what we end up is 2, and it's going to be a half cos theta plus root 3 over 2 sine theta, which then if I expand the brackets out, I end up with cos theta plus root 3 sine theta. And there's not much else I can do with that, but that is that part. So this is hashtag 1. Now in terms of the second, so this bit here, so let's just call that hashtag 2. I've got 2 cos 60 plus theta. So again, I'm going to ignore the 2 to start off with, and then use the double angle in terms of this. So we know that we've got cos 60, and then it's going to be cos theta minus sine 60 sine theta. And we know a couple of these, so cos 60 is a half, and sine 60 is root 3 over 2. So then substituting those in, we get 2 lots of, and it's going to be a half cos theta minus root 3 over 2 sine theta, and should be square brackets, and then just simply expanding the brackets out, we get cos theta minus root 3 sine theta. Now in terms of this, if I then add those two things together, this all equals or should equal 3. So if I just scroll down, just to create a bit more space, so simply simplifying all of this, if I write down all of that, and let's see when that works, there we go. So we've got cos theta plus root 3 sine theta plus cos theta minus root 3 sine theta equals root 3. We notice that a couple of things cancel out, so this plus 3 cancels with that, so what we're left with is 2 cos theta equals root 3. And now you can see where we slowly start to be able to solve this. So from this, what we can then do is that cos theta equals root 3 over 2, and therefore theta equals minus 30 degrees, which is our first angle. And then from this, what we can then do is find our respective second angle, which therefore is going to be positive 30 degrees. So there is our final answer, or if you wanted to, you could write your answer like so, and there we go.